I really liked this quote from the EOS summary article. Petrologists' work with respect to volcanoes can be likened to conducting autopsies.
Empowering Oregon communities to act against water scarcity through geologic maps with Dr. Vanessa Swenton and Geology in a Nutshell, Alyssa Smith with news and research. Welcome to the GSOC Geology Hour. I'm Carrie Gordon.
And I'm Alyssa Smith.
And now over to Vanessa.
Yeah, I'm Vanessa Swenton. Just to give a little background on kind of like who I am and how I got to DOGAMI. I finished my PhD at Portland State University in the kind of spring of 2022. And so I was just hired at DOGAMI in this last December. So I've been here for almost a year now. My background, if any of you remember, I did a talk for GSOC probably, I think it was like my first year in my PhD, so a few years back now. And my specialty, sort of like my background, is trying to understand Eastern Oregon, basically Eastern Oregon volcanology. So I was studying the volcanics of the Columbia River basalt group province, so like the rhyolites there and the rhyolites of the high lava plains and kind of their petrogenesis. So that's my specialty. And I was hired at DOGAMI primarily as a geologic mapper to help with their mapping in Eastern Oregon. But so that's the bulk of my work here. But kind of a smaller portion of how I spend my time is doing a lot of outreach things, specifically for geologic hazards, which is really cool because, as some of you know, I have a pretty big background in teaching and education and outreach. And so it's really cool to be able to take everything I know about the geologic hazards of Oregon and still be able to do the outreach and communication stuff that I love. This particular talk is about empowering Oregon communities to act against water scarcity through geologic maps, innovative outreach, and effective communication. And so what this essentially is a collaborative effort between DOGAMI and FEMA to address this issue. And this talk is basically my Geological Society of America talk that I gave a couple months ago. Oregon has a reputation for its abundance of water. As we know, the Pacific coast, there's the lush green valleys, forested mountains and snow-capped peaks, but 2/3 of the state is arid high desert and deeply incised canyons, which a lot of us at GSOC know, but not everybody in the United States is aware of just how much of the state is actually desert. So if you've ever flown over the Pacific Northwest before, you've probably noticed the rain shadow effect. So this is the state of Oregon and the Cascade Mountains here. And you can see in this Google Earth image how dry it is on the west or the east side, and then how green it is on the west side due to the rain shadow effect. And so water scarcity is amplified by a growing population, changes in industry, and a changing climate. And the variable precipitation and geology from east to west further complicates this issue. So these are two maps from the Oregon Water Resources Department. The one on the left is the annual precipitation map from 1981 to 2020. So again, you have the Cascade Mountains here, and you can see based on the colors that are in the legend here, how much drier it is in the eastern part of the state than the western part of the state due to the rain shadow effect. And then on the right, you have the drought declaration status map for 2023. So the counties that are colored in beige are those that declared drought in 2023. And so this map in particular is showing 13 of the 36 counties that declared drought. And what's interesting to point out here is the counties that are the driest on this map to the left don't necessarily reflect those that declared drought in the map on the right. So what that is highlighting is the fact that one of these things is influenced by policy decisions and one is not. So this is just data on the left, precipitation, and this has to do with policy decisions. And this is why it's so important that there's collaboration between scientists, policymakers, politicians, the general public, stakeholders, when it comes to addressing the issue of water scarcity. So with funding from the USGS state map program, DOGAMI is able to produce these high precision, high resolution, cutting edge maps. This is a kind of simplified version because this figure is really great, but it can be kind of busy. So what I just want to point out is this is the state of Oregon again, and all of the areas that are colored are regions that either were mapped geologically by DOGAMI in the past, are currently being worked on, or are potential projects for the future. So, so for reference, you can see Bend is over here, Burns is over here, Baker City. So a lot of the state is either has been covered or will be covered. And these geologic maps are so important because they provide a stratigraphic framework that hydrologic studies can build upon, and we can get the data that's needed, like 3D geometry and capacity of aquifers, identifying flow barriers, modeling recharge, estimating long-term supply and extraction costs, and accessing water quality and contamination risks. So we can actually get all of that type of information and data using DOGAMI's geologic maps. So the areas that are circled here in red are two hydrologic basins that are being studied right now by DOGAMI. This is the Harney Basin here, and then this is the Walla Walla subbasin that's part of the larger Umatilla Basin. So the reason that these are DOGAMI priority areas right now is because of their geologic complexity. Some of you might know there's just a lot going on in these areas, and it's that complexity that makes them really excellent candidates for this kind of high precision mapping and to actually help with the water scarcity issue. When it comes to deciding what areas that are going to be worked on and how these geologic maps get started with the state map program, it all starts with the community. So it's the boots on the ground, the people that live there, that are experiencing life. They're the ones that will address an issue, a need. They'll identify some sort of problem or something like that that's happening in their area. And because DOGAMI has worked really hard, especially recently, to establish good rapport and positive relationships with the community, when the community identifies these issues or needs, they contact us because they know that we can help. And if not us, it'll be one of our partners, like the State of Oregon Water Resources Department or USGS. And so they'll come to us with an issue like water scarcity, and then we start collaborating with our partners. And they can be partners like these larger organizations like the USGS, but it can also be, it'll be local partners too, like the Harney County Watershed Council and the Walla Walla Basin Watershed Council. So we all start working together, and when we start these conversations and discussions, that's when we collectively recognize drought as a geologic hazard. So in order to address the water scarcity issue, we have to understand what's going on underground. We have to understand regional geology. So once we start forming what the project will look like and how we're going to develop this project, we reach out to our funding partners like FEMA and the USGS state map program for funding to be able to conduct the research. And then we do the science. So we get out there. This is me and some of the other members of the state map team. And we end up collecting all of the data that we need to address the problem. And then the last part that sort of connects all of this together, and arguably the most important part, is bringing all of that data back to the community. So how do we make sure that all of that information ends up benefiting the community? And so this is kind of what my talk is sort of focusing on right now. DOGAMI, when we do these projects, we collect all of this really wonderful data, all of this these high resolution geologic maps with faults. We have magnetic data, stratigraphic columns, well data, geochemistry. We know that this is important in addressing the problem. We know we get excited about this stuff because we know what it's capable of addressing. But how do we get that information effectively communicated to the public and to stakeholders? And how do we get them to be just as excited about it as we are? Because ultimately, if we're not able to communicate this to the public and to stakeholders, then it really doesn't do anything. So DOGAMI aims to raise awareness about water scarcity and the application of geologic maps to that problem. And one of the primary goals is to develop a coordinated communication strategy and innovative outreach techniques. So we work with our partners in order to do that. And one of my tasks in this whole project is kind of this part here. And the ultimate goal is to make sure that stakeholders can make informed management, risk reduction, and mitigation decisions. All of this put together, whether we're addressing the public or whether we're addressing a stakeholder or a politician or whoever, the ultimate driving question is, how do we get a non-geoscientist to care? So there's a lot of different outreach techniques and methods that we were working on. These are all really fun to put together. I know I said this is a smaller part of what I do at DOGAMI, but it's so much fun. So one of the ideas that we're thinking is putting together these trifold brochures. This is still in the works now, so this is just a draft. But the idea for these is to be, imagine what you would get when you visit like a national park or a state park, something that's fun. The idea is going to be, it's concise, engaging, and it sparks curiosity. So the purpose of these is we're going to limit jargon and we're going to make it easily digestible. We want it to grab someone's attention. So whether you're someone who really cares about these things and thinks about it all the time, or maybe you're someone who's just never really thought about this much at all, the idea is we want to increase that interest and sort of grab your attention and make it seem like something that's actually worth caring about if you don't really think about it that much already. And then the idea is at the bottom here, we would have something like a QR code or a link that would bring you to more information if you wanted to learn more. And this one is the draft for Southeast Oregon, but we would also create one. We have one that's made just like this for the Walla Walla Basin. And so that link or QR code may bring you to something like this. DOGAMI has on their website a bunch of these really great fact sheets. So the purpose of these is to be informative, digestible, and usable. You can see these kind of have sort of a textbook vibe to them. This is an example of one that DOGAMI made in 2011 for FEMA flood maps for Coos County, Oregon. So it has more information, more data, more detail. And this could be great for anyone, the public, stakeholders, policymakers, and also people who maybe work in agriculture or educators if they want to learn a little bit more detail. This could be something great. So we would make one like this for the Harney Basin and the Walla Walla Basin. And some of you may be familiar with Esri's story maps. These are so awesome, and we have not yet made one for Harney Basin, Walla Walla Basin. So I included an example of one that you can get from the Esri Story Maps website. This is an example of one that they made called Answering the Call. That's about a search and rescue mission that happened in the White Mountains of New Hampshire. The purpose of these is to be engaging, interactive, and innovative. So the way that you actually interact with this is just by scrolling. So I recorded myself basically like I have the videos of me scrolling through it so you can see how it works. So you'll see there's a lot of text that's going on. There's a lot of pictures, and the purpose of it is to give the information as a story. So a lot of us already know how effective storytelling is in communicating information and how people can remember it a lot more if it's told as a story. So right now it's walking them through the rescue mission. And one of the coolest things is you'll see I'm still scrolling and it's bringing you to each location that's relevant to the story. It actually walks you through location to location. And it's so cool because we could easily do this for our state map project work. We can walk the individual through where we're going and what we're doing, why we're doing it. Something like this can include what our lab work looks like, sample preparation and stuff like that, maybe what it's like looking at thin sections and, building our maps and stratigraphic columns and things like that. And what's really cool too is you can include at the end of one of these basically a success story. So at the end, this is supposed to be when it's all done, we could include like, here's how all of this data ended up benefiting the community. Um, as someone who throughout my whole education, I didn't really do well with just blocks of text and textbooks. I think something like this being so interactive and eye-catching would be great in classrooms. And I've heard a lot of, at GSA, there were some educators who suggested having students actually make these, which would be awesome. Such a great classroom project idea. And then the last one is workshops and field trips. So DOGAMI has a history of putting on a lot of really awesome field trips that showcase Oregon geology and what we're doing and why we're doing it. These are great because they're designed so that, it's not like, some of the areas in Eastern Oregon are pretty rough and hard to get to, but they can bring you to places where we can just drive up, so they're pretty accessible. We don't have to do like miles of hiking to actually see some of the important things that we're doing. And so this is an example of one that was done in the South Columbia River Jetty in Clatsop County, Oregon. But one of these could easily be done for the Harney Basin. So this is the Moon Reservoir in Harney County. And these field trips and workshops are so great. They allow anyone from the public who's just curious to policymakers and stakeholders, people who need to make decisions about things, they can actually see up close in person what's going on, what we're doing, and why we're doing it. So the primary objectives of all of this work is to distill complex scientific information into concise and engaging formats that inform and inspire the public to learn more about these issues and to empower them to act, to make informed decisions, and create a sustainable future. So the second thing also is to keep the relationships strong and this cycle continuing. So the harder we work at this part of the cycle, the more likely this part of the cycle is to continue. So with that, I'll thank you.
Thank you, Vanessa. And oh my gosh, you hit everything spot on. This is why I have stayed interacting with classrooms and youth. And I can tell you for a fact that Alyssa has already started that whole storyline type of thing with how she puts her presentations together. So, and the kids, depending on there's a school in Redmond that I just talked to, and that's exactly what they're going to be presenting in December is their storyline on groundwater. So we do have some questions. I have a question for you too, but we'll get going with one of the questions that came up is Gary asked, the DOGAMI project map is illuminating. Is it more likely for proposed projects to be approved when they are more multidisciplinary in nature, potentially affecting more stakeholders? And perhaps a question for both Vanessa and Brittany, are the new multidisciplinary class offerings emerging from the new PSU C's college?
I actually attended my first, so like I said, I've only been here for a little less than a year, but I attended my first, it's OG MAC meeting, which the acronym is not really important, but the idea is that's like the meeting where they decide where the mapping priorities are going to be and for the next fiscal year and sort of what we're going to propose for USGS funding. And it's really interesting because it's members of DOGAMI, but it's also people who work in water. So there's some people from FEMA, there's some people from the Oregon Water Resources Department. And in that way, it is kind of multidisciplinary, because I was able in that meeting to hear, it was basically like there's a bunch of voting members and they're able to say, I'll go back to so they're able to, if there's an area, I know this map is a little bit older, but where it says on the top, state map project areas for future consideration, there's some of these in this color here. Basically, the meeting will say all of these areas, and people will be able to give their input from all of their different backgrounds and, affiliations, agencies and stuff. They'll say, it's really important for us particularly to be looking at this area, for example, or from a water perspective, like we really want to have all the mapping done for the Willamette Valley or something like that. So it is really important, because we, as geologists, sometimes you get a little bit carried away and just the like, this is really cool, and that's not really like necessarily the best reason to prioritize an area for mapping, but it keeps us sort of focused on DOGAMI's general like motivation, which is helping the community, like providing the data for everyone to benefit from. So yeah, I think that answers at least the first part of the question, and maybe Brittany's got the second part.
I guess I think the idea with these, and I know that John Bershaw, our current chair in the geology department, his driving force for geology to be part of C's was to have that flexibility and be able to take different courses that would still fulfill requirements in the geology department. And the last talk that we were having about what geology will do in this new school was offering more like specific tracks that students could take, and in those tracks offering classes in the geography department that they could take, or anthropology department. So it is being talked about, and we'll see what comes of it, but it sounds like overall they want to be more flexible, and they want more students to graduate with a geology degree, and maybe having a more track focus or just more flexibility will help do that in the new school.
Yeah, so that's wonderful to hear, because one of the things that I found as a retired geologist with 40 years with the Forest Service is that I met a lot of geologists, but they were working as archaeologists, as hydrologists, as fish bios. So we kind of snuck in a lot of different areas. I worked in the engineering field. So Vanessa, I'm usually at the AUGMAC meetings because Jason got me involved when they were mapping here in Central Oregon. And one of the things that I would hope you're doing with your brochures, please, 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 is reach back to those existing brochures that are really hard to get a hold of, that illustrate our geology. And I'm speaking specifically to the Wildcat Mountain brochure and the Crooked River Caldera, because talk about explaining groundwater issues. Those are two key brochures. Yeah, they could use maybe some updating now that Jason's got the map done. But but the thing is take advantage of pre-existing documents, because you don't need to reinvent the wheel necessarily. You can dress it up, but please reach out. And I love hearing this.
What's being done to really consider accessibility for these outreach products, and kind of specifically along the lines of having things be available in multilingual formats, also having like online published materials that are easily read by screen readers and things like that. I just wanted to know kind of, what's being done.
Yeah, that's a great question. I know, so we have an outreach kind of, I think he's like publications coordinator person who is in charge of like anything that gets put on the website pretty much. And I know his plate is really full, but usually if I tell him, this is something we should consider, then he's like, he's on it. So we have a few Spanish speaking coworkers here, for DOGAMI staff, and I know they would be definitely interested in making a Spanish version at least of this. And yeah, that's a great idea. And I know DOGAMI also is putting a lot of emphasis also on making things that are easily readable for people who are colorblind. So sometimes it's hard when these maps have like 50 different units, because at that point it's like you start to have to resort to patterns rather than colors, and then it can become just like like a, you know, some crazy thing. But yeah, that that is a good idea, and I think it's worth bringing up to our publications coordinator. And then what was the second part of the question?
Oh, asking about accessibility for like digital materials for people who are
Mhm.
using screen readers.
Yeah, so that's a good point. And the Dogami website is currently like under major construction. I know there was no one was really editing it for a while, and now we're trying to just make it so the stuff is easy to find. Because I know USGS is also having issues with, it's almost easier to just Google search like USGS, whatever it is I'm looking for, than actually navigate through the website. So we're kind of going through the same thing. And that's a good thing too, is for like screen reading. Yeah, I don't know if that's on their radar, but it should be.
To tie into that last comment, the most threatened areas are likely to be also the most resistant to facts and suggestions for change of habits, in denial and angry or numb. How can these projects overcome all that? And I know from experience that Jason and McClary and Mark Ferns made a strong effort here in Crook County, and also in a couple stakeholder meetings that I attended in the Umatilla Basin, to get out with the stakeholders and meet with them. I'm assuming the same thing has been going on in the burns for those. And I know that makes a big difference because you're getting the stakeholders in. And I have another stakeholder that I didn't see you mention. Speaking of crossing boundaries, Society for Range Management. That is a strong OSU has a strong range program, and actually connecting with SRM, which is where I've done a lot of geology talks, I've infiltrated. They're not just range and soils. So I think that group is one of those that would be a good addition, especially in the eastern side of the state, because that's getting into talking to a group of people that are very concerned about the landscape.
So we're trying to make this was actually brought up too, with the way that the trifold brochures are meant to be sort of like fun, eye-catching, almost even a little bit playful, sort of. We're also trying to create a version that is a little bit more like clean cut, and has some sort of, you know, just because if I guess the way that we were thinking about it is, if we're trying to put our minds in, like, if you were a rancher out there and you hadn't really thought about this stuff very much, or you know, you maybe just like didn't have a lot of positive experiences with thinking about this stuff, it would be more effective to hand them something that looks a little more clean cut. So we've thought about kind of how each, not just like public versus stakeholders, but like individual public audiences may receive some of this stuff, and we have to kind of change our approach a little bit. But one thing that I know is really important that we are pretty adamant about is we are trying to make sure that we stick to facts. So if someone doesn't enjoy the facts, or like they're uncomfortable by like the facts that they're reading, you know, like we're not going to lie or provide misinformation because it would make someone else more comfortable. It's kind of the, you know, we're providing real, true information. So
Vanessa, this has just been absolutely excellent. Thank you.
thanks.
This has
Yeah, and
been wonderful.
if anybody wants to
Alyssa,
email me, oh, sorry, I was going to say, if anybody wants to email me with any questions, I'm happy to chat more.
Alyssa, what have you got for us?
So today I am going to be doing this segment that I've been continuing, which is I've been referring to as geology in a nutshell. And my goal with this has been to summarize some recent research So you can have it in a faster, ideally more digestible format than just going straight to articles. So let me take that burden off of your plate and I'll put it onto mine. For today, my first bit is going to be talking about volcanic anatomy and what scientists have learned from the 2021 eruption of Tahugayete. And then looking at a more sustainable future for the rare earth industry. So first off, this article or this summary of some recent work was called Volcanic Anatomy Mapped as it Erupts, as it was represented in the October 2024 EOS edition. But it's a summary of several different articles that have come out from that event. So to get us oriented, we're going to take a little airplane ride to the Canary Islands, but also we're going to hop in a time machine and go back to September 2021. So if you're not familiar where Tahogayete is, and there's a good reason for it, as I'll mention, it's going to be the island of La Palma in the Canary Islands and off of the west coast of Africa. So this was really important because the area, which is known as the Cumbre Vieja volcanic ridge, had been quiet for about 50 years. And then all of a sudden, there was about 8 days of notice between some of the first really strong signs of eruption and when there was a volcanic event. So I was trying not to spoil it beforehand, but essentially this is a brand new volcano. And it just popped up. It was given the name Tahogayete, which I believe is the correct pronunciation. Almost none of the videos I looked at pronounced it. So this was a small vent that erupted about 200 million cubic meters of lava over about 12 square kilometers of La Palma. And so this is a picture here of the eruption event at night. As far as the actual volcanic activity goes, there was a Strombolian event which built up this little cinder cone, and it was an explosive event with fire fountaining that constructed this cone. But the bulk of what happened was effusive volcanism, so fissure-fed lava flows, and that was one of the biggest hazards from this. So because scientists were doing their homework and paying attention, they were able to successfully evacuate about 7,000 people in the surrounding communities. And regardless of this, I mean, that's a huge success, you know, because you can't put a price on human lives. But the after effects resulted in more than about 842 million euros in damages. So this is one of the lava flows that came into town. And so because you can't exactly pick up a lava flow and move it, the construction efforts are going to be kind of difficult to, you know, kind of get around these lava flows. So this diagram here shows some of the seismic events that happened, and there were some signals from gas emissions and an uptick in seismic activity as early as 2017 that started to signal that something is likely to happen, but there's no way that people could know how far out that could be. And each of these circles is a seismic event. So fast forwarding to 2021, there was this big uptick in seismicity, and by September 19th, the kind of main event started to happen. So that's that blue dashed line in this figure. So there were some signals of the impending eruption, like the seismicity, but also things like ground inflation and increased gas emissions about 8 days prior to the eruption. So as I mentioned, that was what allowed them to be able to evacuate people. So one of the cool things about this eruption is that there was real-time data that was coming in, or that were coming in, and scientists were able to look at these data right away. And that's what allowed them to help people get out with, you know, loss of property, but not a huge loss of life. I believe there was one casualty in this event, and I am not sure the background there. So regardless of the catastrophic damage to infrastructure, roads being taken out, buildings being taken out, the loss of life was minimal. So in the time since the eruption, there's been a ton of additional information that's come in, including geochemistry, seismic tomography, melt inclusion and mineral work, that scientists have been able to look at these things almost in real time to get a deeper understanding of the eruption in just, we're about 2 years out now from that. And there's been just a huge expansion of our knowledge of not only just this volcano, but kind of how these systems work and how these data could be collected in the future. I really liked this quote from the EOS summary article that petrologists' work with respect to volcanoes can be likened to conducting autopsies, providing insights into the causes and behavior of eruptions after the fact. So I really like that, and not just because as somebody who identifies as a petrologist, it makes what I do sound really, really cool. So in the case of these articles, they're kind of looking at petrology as an interpretation of magmatic systems and evolution. And what some of these articles were testing is how fast they could collect the chemical data. So they called this a rapid response approach, and a lot of these samples were collected within a week of eruption. And I mean, this is very much within a week. You can see the event is still going on there, and that individual is collecting samples. Couldn't be me, but actually it probably would. But petrology is often underutilized in understanding volcanic crises kind of as they occur. We see petrology almost as an after the fact tool. So this is something new. So as far as some of the just general things that they found is that these lavas are highly alkaline, and that's what they would expect for lavas in this part of the world. Other Canary Island lavas are shown on this diagram in that gray field. And so these fall right in what they would expect. But if you are a mineral nerd like me, you may be wondering about, well, did they have a lot of feldspathoid minerals in them? They did not, actually. So if that was your question, there's your answer. So they, even though these would plot in sort of the tephrite basanite field on a TAS diagram, if you're familiar with these, they'd classify these instead as alkali basalts. And the part that's interesting, I hope for everybody, is that what that means is there's a high degree of mantle melt that they would expect with these types of compositions. But then they also found that there was a pretty complex crystal cargo associated with this. I brought in some of the images from the article, so just a lot of diversity in what was brought up. So those are things that they can continue to look at further to see why it is that they're getting minerals maybe that they wouldn't expect. So one of the coolest parts of what they did in this was called microthermometry. So the image on the left, the top one there, shows some fluid inclusions, and mostly CO2 and water that might be trapped in olivine and pyroxene minerals in these lavas. And what's important about looking at these gases is that they can give us kind of an idea of the plumbing system of the volcano prior to eruption. So they can figure out where things may have been sitting in the crust or below the crust before they came up and erupted. And what they found with these early analyses is that the depths they were able to determine with the gases trapped in, or the fluids trapped in these little bubbles, is consistent with the seismicity that they were seeing before and during the eruption. So that's really, really big. And this is a diagram that they put together to show they classified a few different phases throughout this eruption. It occurred over, I think, a 3-month period. And what they determined just from looking at the minerals they collected during and shortly after the eruption is they were able to see that there were specific like pulses of activity in different batches of magma that were being brought up and then erupted as lavas. And that's incredibly significant. And so what that shows is that they're able to use these rapidly collected samples to connect the depth at which these minerals are equilibrating and with recorded seismicity. So this is a really, really powerful new tool, or it's basically a new data application that has the potential to set the new standard for combining these forms of data as eruptions occur. So this is a really, really interesting collection of work. I highly recommend taking a look, and we'll include the links to the different articles in the show notes. So to transition on to a tangentially related but also quite different subject, we're going to be talking about kind of thinking about sustainability for the rare earth industry. So this is a new publication that was put out through AGU and Wiley Publishing. That's a text for science and engineering students, researchers, and industry professionals that kind of are concerned with figuring out how to use new sources and for rare earth elements and new methods for extraction to meet increasing demand. So it doesn't help if I mention rare earth elements and not define them. So here is my best friend, the periodic table of the elements. And we're going to zoom in over here to take a look at, these are the rare earth elements as we would typically think of them, which are the lanthanides, AKA the very bottom of the chart that your chemistry professor told you you never had to think about. So surprise, here we are. But in the context of the applications for materials we're looking at, it's not just going to include the lanthanides, but also scandium and yttrium, which are pretty similar and line up with these in behavior. So as far as uses go, rare earth elements are in a lot of our technology. They help power our phones, they're part of computer hard drives, they're an important part of electric and hybrid vehicles, but also they're present in magnets and things that are in a lot of other devices that you wouldn't think of, like headphones and whatnot. So as they try to produce smaller and smaller versions of things like headphones or even our phones and computers, they begin to rely on more powerful magnets. And so rare earth elements are going to be involved in that, specifically neodymium. But also it extends beyond just our daily life. And these are important components in things like lasers that are, lasers have a lot of applications, but also things like radar and sonar that are important for like defense purposes. So there's a lot of applications, and it's expected that demand is going to only increase over time. And depending on which source you're looking at, there's expected to be at least a 3 to 7-fold increase in the demands for rare earth elements in the upcoming decades. One of the aims of this publication is to detail how these rare earth elements are produced, and the steps for the production are going to include recovery, processing, and purification. So this is a view of the Mountain Pass mine in California, which is the only rare earth element mine producing in the United States. What it means for the recovery part of the production is that they're physically extracting rare earth elements from the original material or sometimes secondary products. So that could include things like the ore, but also mining tailings and manufacturing wastes and life materials from other sorts of mining. And the products are not usable in this format. They need additional processing. So they come in and then they're in some sort of a mixture, and then they need to be upgraded is the verbiage they use there. So that brings us to the recovery process. So processing is going to be separating the rare earth elements from the material itself. And this is going to vary a lot between sources, what you're taking things from, but it can involve things like solid phase extraction, bioseparation, or other complicated processes I'm not going to pretend to be an expert about, but cool sci-fi lab stuff. And the product of this stage is going to be rare earth elements that are low in impurities. Some of these are going to be like the element themselves isolated at this point, and some of them will need some more processing. So that brings us to the purification step, which is where if the material was not ready in the previous step, you'll need further separations. And the end product is going to be whatever material is going to be supplied to manufacturers. One of the biggest issues with rare earth element production is that there's a very, very high waste to yield ratio in processing these materials. And it's estimated that 2,000 tons of waste are produced for every 1 ton of rare earth elements that they're able to extract. So that's kind of a big problem. So one of the next steps then is going to be in thinking about sustainability is going to be increasing the range of sources where they're able to take these materials, which is going to mean things like not just looking at the same countries that are producing right now, but to see if there's a variety of places where they can source things. Also different minerals where they can use to extract the elements they're needing, and trying to find more like end of life products that would be waste anyway, and trying to extract whatever's left from those. Also, there's been a lot of talk about using alternatives for rare earth elements where possible. That's something that is kind of just part of modernization. And as time goes on and we change the way that we're doing things, the industry ideally will modernize, and this process can be a lot more streamlined. So it's definitely a developing story. It's something that's very important to all of us, especially since we are all tuning in from some sort of electronic device. And we'll just kind of see how things unfold as we move forward. So that is going to wrap up my little segment. And ideally, we'll do this again next month. And as I've said before, if there's any sorts of specific things people want to hear about, I am always up for suggestions, but check back soon for more recent geology research.
Oh, Alyssa, thank you so much. As always, you dive into things, and I love it because you're reading the EOS and I'm not, even though I get it. So thank you so much. What criteria do you use to select topics for geology in a nutshell? Are you able to make it personally meaningful by selecting areas that relate to your work and are of deep interest to you?
That is a good question. So largely, I try to not just make it what's interesting to me. If that were the case, it would be a lot of chemistry, a lot of volcanoes, and I know that's kind of what we did today. But I mean, these were, I look for things that are recent and things that have either, like EOS is one that's really, really useful. That's the one I go to the most frequently. And the reason for that is that if I just refer people to a bunch of scientific articles, they're not going to be able to necessarily go through it with the same level of detail. So I've been prioritizing things that either have plain language summaries or that are summaries for a broader audience. And then those are things that will have citations to the original articles if they choose to go further. But I don't want to make a barrier right away if I send people to an article that is completely, just 100% jargon. So that's one of the big ones. I also look for whatever is recent. So in my area of the geology world, there is kind of a trickle of new stuff that's coming out in the Cascades, but it's a faucet that I think is turning up as we go. But just trying to find a variety of different topics has been my priority. And I know probably there is some bias towards more volcano and chemistry things just naturally, because I'm like, oh, I can explain this better than maybe like if we're talking about glaciers or deserts or things like that. I think of myself as a translator now, this far in my education, and ideally I can access those things and deliver them in a more digestible format. But that's kind of the big thing guiding my selection for these.
Well, I think it's working.
Thank you.
Olive says one of the quote of one of the lava flows that came into town is this terrifying sentence, and I agree with her.
Yeah.
That's pretty scary. You've got lava flows coming right into town and overtaking, but that
Absolutely.
connection between taking samples right away to the seismic. Oh my gosh,
Isn't that
huge.
just amazing? Like, what a beautiful thing. I mean, when we talk about interdisciplinary, that means within geology too, because there's not enough talking between people who do different things in geology, let alone people talking to people outside of geology. So
Yeah.
that connection between current seismicity and petrology is huge. And I just think it's really, really neat.
Can we recover the rare earth elements through recycling? A side idea on that is it possible? Are we looking at synthesizing rare earth elements? And then the biggie that I know I worked with is what kind of waste is produced by the rare earth mining and extraction process. So that's, how do you take care of all that waste? But are we already looking at synthesizing these rare earths, and can we recycle all of our handy dandy technology?
As far as synthesizing goes, I'm just going to say no. So the thing is in order to create elements, it is a tremendous amount of energy that would be needed. And just understanding, so if we think kind of a little bit more simply, and this isn't quite correct, elements are about as small as we can break things down. So elements are made up of other things, but they're pretty set. So trying to create new versions, like if I were to try and create a dysprosium atom, that just, it's very difficult to do. And so that just wouldn't be a sustainable way to do it. So basically, we have to think of how to just get these out of other things. So I'm hoping that there's a lot of push for reusing. I was hoping I'd find that in the articles. And I didn't realize when I was putting this together that the book that this is coming from is like a $200 book. I had no idea. I might have chosen something different that was more accessible to all of us if I had known, but it's something, I don't know. Yeah. So hopefully there's more of a push for reusing. As far as where they can get like the waste products, I don't know all of the specifics, but let me pause while I go through all of these little animations here so Paul can edit that out.
And we're coming up with 2 minutes to the end.
Okay, I will go quickly. So this image here is from a mine in Australia with the kind of the tailings and things there. So that gray material in the front is some of the waste produced here. And from what I understand, it tends to be pretty gnarly stuff. And one of the ideas with why they want to use some of the tailings from this is that there is some amount of rare earth elements in there, but it tends to be really dilute, which is why they don't go for that first. So one of the things that they want to do is to develop more sustainable, cost-effective ways to extract the dilute material from the waste to get more out of it. And that honestly benefits everybody involved.
It really does. And I know it's happened with other mining industries like gold and silver. They figured out ways to extract those going back through the mine waste. So we'll probably get there at some point. Thanks for joining us this week, and tune in next month for more GSOC Geology Hour.